Good afternoon, everyone. This is a recording of me just refactoring some code in a crate that I have called readline async, and also kind of demonstrating how refactoring such a crate might work. This is a new crate. I'll explain why I even built this crate, and it was a yak shaving exercise, which ended up in having to build something that's pretty low level. But the nice thing is that it kind of demonstrates a lot of really cool concepts around command line interfaces and like how what the mental models are for how you should really even think about um, you know building a command line interface. How do you make it interactive? How does it do what it does under the hood? And so this will be hopefully serve as a like an exercise in going through that. So let's set the stage. So the crate is actually called readline async, and I forked it from another repo, but I'm making some substantial changes to it, and I will rename it to probably readline async rather than readline async. And where it stands right now, I can show you roughly what it does on this, if you can see this screen. So this is the crate for readline async, and it's on GitHub here. It's this Nosmal Idris readline async, and there's actually a bunch of open issues if folks want to look at it and start contributing. So this is essentially, there's the README is pretty good. It has a whole bunch of information about like why this crate even needs to be built and what it does and where it fits. So if you're interested in this, I definitely encourage taking a look. And here's all the issues. Let me just demo to you what this thing does before we get too far into it. So this is just a VS Code, and there's just Rust analyzer, and so I'm gonna say cargo run example readline. So if you notice, it says available commands, and it goes start task, stop. Let me just full screen this. So it goes start task, stop task, and so on. These are all the commands that are available. If I hit up, down, it has history, which is pretty cool. So if I say, so if I partially do start and then I hit up, it's pretty smart. It just like auto completed it. So when I say start task, what it does is that it spawns a Tokyo task. So basically, in Rust, there's such a thing called the Tokyo runtime, which is how you do asynchronous in Rust, and that's like the async in readline async. So if you noticed, as it's printing things out, the prompt keeps getting pushed down farther and farther, and you can actually manipulate the prompt. This is not something that you can do with readline, or most command line interface applications that you would build using readline, which is pretty much all of them. It's kind of crazy. It also has history. And notice the tasks are continuing. They just keep going. And nobody's clobbering anybody. So let's do start task 2. Notice that now, so start task 1, actually what it does is just kicked off a task. It just runs every second, I think, and it just prints something to standard out. And what task 2 does is something much more complicated. It uses something called Tokyo tracing, which is this awesome library for that comes with Tokyo. Tokyo is the async runtime for Rust, and it allows you to do instrumentation. You can think of it as like logging on steroids, and like Google Analytics and Sentry and everything all rolled into one, and it's just magical and amazing. So this actually has Tokyo tracing going, and what it does is that there's a task. All it does is that it just dumps a log message, an info log message every 4 seconds. And as you can see, it works. So now you can say there's something strange called start printouts and stop printouts. So if we do stop printouts, what it'll do is that when you type a command, normally it shows the command and that you've typed, and it's in the history. But because I said stop printouts, you won't see it. So if I say start print, you can say command I typed. So you can see command I typed, but if I say stop printouts and say command I typed, you won't see it. It just says unknown command. So that's what that is. It's pretty cool. Finally, we have exit. So that is, in a nutshell, Rusty Line Async as it stands today, which is pretty cool. So there's really like there's a main the main program to look at here is in the examples folder. There's something called readline, and readline is meant to be like a very general purpose, almost skeleton for a command line interface application that you might build in a REPL. And you're like, what's a REPL? Let's see what a REPL is. It's read eval print loop or read execute print loop. And so you've used this if you've ever used Node.js or Python or any scripting language. They all pop up a REPL. If you've ever used Bash or Fish or Z Shell, you're using a REPL. So the idea of the REPL is that there is a prompt. By the way, you can tailor this prompt to whatever you want down here. Let's make this bigger so you can see it. So down here, you can, in the prompt, you can type in a command and then it'll process it. So if it's a command it understands, then it'll do something. If it's a command it doesn't understand, then it'll just say unknown command. So this is just like a bash, bash script. Or bash shell, sorry. So let's see. Let us close that. Okay. So normally, when you have these REPL type structures, there's a main function. So let's see. And in that main function, what it does is that there's some kind of a loop, and the loop blocks on the main thread. And when the readline function is called, so there's a readline function, which is this thing, Rust readline stepper library. So you can see right there in standard in, there's readline. So that's the readline, the venerable readline that's been around since forever, basically. And so the way it works is that you create a buffer, then you call readline with that buffer. It's mutable. So whatever you type, then you press enter. That content will then show up in the buffer. And while you're typing that content, the main thread will block and your program will be frozen. So anything in the background, if you have stuff running in the background, it'll still run, but when you write things to standard out, because there is the standard in that's blocked, they'll kind of clubber each other. Because when you do print line or console log or write anything to standard out, the assumption is that the caret or the cursor is at the bottom left-hand corner or the far left of an empty line. So what happens when you do readline is that it moves that cursor somewhere else, that caret somewhere else, and it's not where it should be, at least from the perspective of standard out. So if I were to draw a diagram, and by the way, in the README, I go through this in quite a bit of detail, so you can even see, like, everything that I'm saying is actually written here. There's other downsides with readline being blocking. Essentially, when in Rust, there's no such thing as you can't preempt a thread once it's blocked. So that means you can't kill it. So only way to kill the thread once it blocks itself is, or an OS thread is, you have to kill the process, and that's ugly. And you kill a process by calling process exit, or you kill a process by generating a panic. Both are unappealing for the purposes of gracefully exiting a process, because that's not graceful. So yeah, so check this out. this kind of goes into the, and it's in that, where is it? It's in that README. It's all in here. So if you read that, that's the nice formatted version of what you're seeing here. Okay, let's go back to the issues. So now, let's see. We were in standard in and standard out. So let me just diagram this real quick. So basically in an operating system, you have, let's see. So here you have, zoom in so you can see it. How do you zoom in? Okay. So in an operating system, you have standard in, standard out, and standard error. And these are basically constructs that are given to you by the OS itself. So whether you're in Mac OS or like Windows, or actually Windows is an exception, but if you're in Mac OS or Unix, Linux, any kind of Unix, any kind of POSIX compliant operating system, you'll find that this is the case. So you can Google what is POSIX. Actually, this is a good one. By the way, if you wondered how I quickly did that Go link, I have an extension called R3BL Shortlink you can check out. It's really cool. It can boost your productivity quite a bit. It allows you to basically just make up your own names. It's like a replacement for bookmarks. So you can just say like, Docker. So you can make your own Docker short link and you just say go Docker and then it'll just open all the tabs. And it's really cool. You can also export it and share it across your multiple machines. It's pretty awesome, and it's open source. So check it out. Okay, so in this onboarding document, there's a whole host of information around what is POSIX and what terminals are in copious amounts of detail. Definitely check it out. There's also a bunch of really cool videos that kind of take you through what the heck any of this is from an operating system perspective. So if you're new to REST, if you're new to terminals, if you're new to command line interface, new to text user interfaces, this is definitely, read everything on here, go through everything on here. It might take a long time, but you'll be in good shape. Okay. So coming back to here, so if you, there's a standard in, standard out, and standard error. So you've actually used all of these probably. So standard in is anytime you do something like, let's send this to the back. So anytime you do something like, why is this sticking like this? This is strange. Come on. That's weird. Oh, that seems to be a limitation of this thing. Okay, let us adapt. Let's take this out and we'll do like this. We have an OS. And let's say in the OS, nope. How do you do top aligned? Why is it so hard? That's weird. Huh. How do you do top aligned? You can do left, center, right, justified. Okay. That is weird. Okay. Let's abandon that and let's do this. So we're going to have a box. Inside of that box, this is our OS box. Seriously? Huh. Must be missing something here. No vertical alignment. Strange. Okay, moving on. So we're not going to do that. Let's do this. Let's make this bigger. Let's do this. I think maybe that's why they have these things. Let's do 16. Because we're programmers, we're going to do a programmer font. So I'm going to leave this around as, okay. So this is our POSIX compliant OS. And here we have, let's say, we had like this standard in, standard out. Those are called streams, by the way. And streams are basically a source and a sink for bytes. in an operating system. It's a way, an array of bytes is called a buffer. So it's just a way for you to, so it's an abstraction to allow you to transfer any things in and out of memory, basically. And files are those things, network IO is those things, and so on. So let's just put this here. So this is, we got our standard in, the 16. Wow, this tool is terrible. Absolutely terrible. Okay, so we do like this. Standard in, we got standard out, and we got standard error. And then what we can do is, for standard in, you do basically this thing. Okay, why is this being so strange? Let's see. I wonder how this works. Arrow. Nope. Oh, I see. So the green dots. Oh, okay. So this is read line, which is blocking, by the way. So basically, this is the thing that we've been using, let's say, in most command line interface programs. Standard out is also something you're used to. It's every time you do print line macro or print or write with standard out, and this is eprint line. So these are all Rust things. Okay. So for some reason this is line and that's ln. So this is essentially, you can think of it this way. That thing is a blocking operation. This also is, when it does a print line, it also blocks. So under the hood, basically, when you do a print line, the code looks something like, and this is a gross approximation, but it goes something like standard. From the standard library, it gets standard out, then it goes dot block, then it goes dot write, and then it writes something. That's roughly what happens every time you do a print line. So, and again, these are just rough. You can actually go inside the print line macro and see what it does for reals. I'm just like making stuff up to a degree. Okay, so there you go. That's essentially, I can see there's like a lock here, which is kind of interesting. Like, what is this lock? So the lock actually makes it so that when you have concurrent access to standard out, only one thread can get in at any given time. And this is why when you have multiple threads or tasks, Tokyo tasks, which run concurrently or in parallel, when you have them doing print lines, they kind of show up and sometimes in a sequence in which you don't expect. So that's what's going on there. Okay, eprint line is the same kind of thing, only it dumps to standard error. Readline is, you do standard in.readline or : readline, and that basically pulls something in from, let me save this real quick. So pulls it in from here. So you can put that link there, and this is, I don't know if you can hyperlink. Can you hyperlink? Never mind. That is not a thing. Strange diagramming tool. Okay, let's just do this. So you can read more about it here. Let's read line. And then can leave that here. Okay. So, all right. And then, okay, so that roughly gives you a sense of, POSIX compliant operating system. And essentially when you run a program, you're waiting on the user for some input, and this is a command line interface program. So like, examples are git, right? So you say git, or you say sudo apt remove, like that, right? Ubuntu pro client, whatever that is, and it goes, do you want to continue? So this is a read line in action, and it's blocked, by the way, until you press yes or no. Apt, the process, is frozen. That's what that means. So you can control C out of it, or you can press no, and that'll just kill the process. So that's an example of, like, most command line interfaces. It's pretty simple, pretty cut and dry, not a whole lot of things happening in the background. So The whole purpose of this readline thing is such that you can have multiple tasks which are concurrently generating output. So that's the kind of like the whole reason they add for this thing, like the whole reason for being. So let me see where I put this. I think I put this diagrams. Yeah, so I'm gonna do these diagrams are now part of the. I haven't linked it to the README yet, but it's at least in GitHub repo. So if you go to the repo for async readline, you'll be able to find this diagram that I just made in docs right there. And you can just open this in draw.io. It's a free tool. It has its limitations, as you saw, but it's okay for the most part. All right, so now let's go back to this tab and I think we're done with that. Okay, so let's see. So that was readline. So how is this actually used in quote unquote the real world? So this is a different repo. This is called tcp-api-server. And so let me go find it. Nope, it's not there. Should probably just save a link to this. No, Rust Scratch. Yeah, there it is. Okay. So I'm going to put a link to this in the README, because why not? This is that repo, by the way. And it's pretty cool in VS Code now. You just paste into Markdown and it just works. It is smart enough. Anyway, let me just save that. And let's just... Okay. So, long story short, we have this thing called tcp-api-server. This is 8-bit graphics. And it essentially... there's a client. This TCP-api-server is just one binary. It's just a process written in Rust, and it exposes a client and a server in the same. I don't know why this is uppercase and that's lowercase. That's weird. Let's fix that. Let's see. Why is this uppercase? Okay, and then let's save that. Okay, so we have oh, where were we? Oh, there it is. Sorry. So we were in this TCP/API server. So it's a binary. You can run it. You can just say cargo run right there. If you want to see it dumping stuff, help output, it's really good actually. There's this thing called clap. You can do this. Create actually docs rs clap. This one, command line argument parser. It's you should definitely learn this if you're doing command line interface stuff in Rust. It's just a way for you to very easily parse command line arguments. Like cargo itself uses it, so it's not the greatest thing, but it is what it is. Everybody uses it. Like it's got a lot of uses on. If you look at crates and you look at clap, you'll find like there's a gazillion people using it. Look at that. That's a nice number. Just to give you some perspective, our crates are missing 3 significant digits relative to that. So that's all the rebel stuff. Anyway, so that's clap. It's good. Check it out. So cargo run dash dash help. So that's what happens when you run this thing. This is the. So you say cargo run dash 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 help. As you can see, there's a lot of dashes. So that's a cargo thing. So if you don't want to do that, you can say cargo watch, which is, by the way, another tool you can install using cargo install cargo dash watch. And what it does is it'll just constantly keep building your code whenever you change it. I actually have cargo watch running here. Where the heck is it? Somewhere here. Rusty line async, TCP/IP. Yeah, there it is. There it is. So this basically I have this cargo. Anytime the code changes, I just rebuild it. So here, so then because I know that this code is always being compiled and up to date, I just do this. I say target debug. So this is where Rust stores its stuff. It puts it in. Oops, what the heck? By the way, this is a program called Ranger. You can install it. You can say brew if you're on Mac. You can say brew install Ranger if you're on Mac. If you're on Linux, brew. You can say brew install ranger. If you're on Linux without Linux brew, you can say sudo apt install Linux, ranger. It's a really nice command line interface file manager. So here we have essentially the target directory. Sorry about this overlay. Here it is. And inside of that, see this green thing? That's the binary, ELF64, blah, blah, blah. That's the Linux binary format. So you can actually run this directly. So you can just say mix. Wow, it even auto-completed it. Okay, so you just say like this. Ta-da! By the way, if you guys are into keyboards, this is a good one. If you're the sounds of what you're hearing, the thwacks, that's all this thing. It's epic. Absolutely epic. Best thing ever. Okay, so let's go back to where we were. So here we have, this is clap, by the way, and you can customize the hell out of clap. I plan to write lots of tutorials on Developer Life as a follow-up to the stream, so I have a lot of to-dos that I need to get through over the next couple of weeks. So here, you can just see what all the capabilities are. It's quite sophisticated, and I definitely recommend that you check out how this is implemented. You start in the main RS and work your way through there. You'll find it all in there. Amazing stuff like tracing setup in it. And let's introduce terminal async. This thing. This thing is a thing that I made to use Rustyline, our friend here, to be able to do asynchronous I/O. So let me demo this to you. So you say target. So you can say client, and I already have the server running, by the way, in here. I have it running here, right there, somewhere. No, where do I have it running? Huh. Okay, I have it running somewhere. I have too many. I have a lot of these. Oh, right here. There it is. So this is the server running, by the way, in case you're wondering. Let me make this bigger. This is the, that's not really helpful, but that's the, this is the TCP-API-server binary running. So I basically just said, like I just said, server, and then let's see, does the client work? Yeah. There's some bugs I need to fix here, by the way. I'm in the middle of putting Rustyline async in here, and I actually had a older binary. Let me do this. This is a work in progress. If you look at my commit, it says work in progress. This is not even close to done yet. So let's do some monkey business here. Oh wow, that killed it. So let's do this. Oops. So this one died. Yes, and then let's spawn another one. Okay, so let's just do, I think we were in tcp-api-server. So git status, let's do this, git log. So what we're gonna do is something really sketchy. I'm gonna grab that commit. Let's say git checkout. I could have just said head 1 that, grabs the previous one. Then I can say server. So this is the old binary, and I can say git checkout main. Again, don't do this. This is bizarre land nonsense. So I have like, this is the old server, and this is the new server. This is the new server. But this is not using Rustyline. This is using Rustyline. But they both communicate over the same protocol, so it all works. They all speak the same language, so to speak, this TCP protocol. And we'll get into like what the heck this TCP API server is later. It's a general purpose backend. So let's start it up again and see what it did. Notice this. There was this. I don't know if you saw that. There was a nice it's a bit of an animation. It's I built it yesterday. It's a progress bar. So basically what it does is when you start the client, there's a whole bunch of these delays we can muck with. So I'm going to slow everything down so you can see what the heck is going on. So there we go. I don't know if you saw that animation happening. Lots of dots, lots of dots. Oops, 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 oops. And it overflowed. There we go. So clearly a lot of work needs to be done. So it actually looks better when the zoom isn't so crazy. So if you do on a smaller zoom, it actually, like, this might be too small. Yeah, there we go. So this is what it's supposed to look like. Dot, 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 dot. And then when it's done, it cleans up after itself and then says connected to server. And then these are a bunch of like those Tokyo tracing log messages that are being dumped. And essentially, like, then, like, it's kind of like there's a bunch of tasks that are running in the background. So this one is doing a bunch of stuff. This one is doing, you can see the thread IDs are different here. This is a prompt essentially. So, and this is all really ugly output. And you can turn it all off. You can just say configure tracing none, and that's what it looks like. It's much cleaner. That's what the UI is actually supposed to look like. But I put in a lot of stuff there so that we could see what happens. So here it says enter a message, and then see this prompt. This is just a string that got dumped to standard out. This is just a message that came in from the server, and this prompt is what you can type now in the terminal. So it's pretty sophisticated what's happening here. But let me just kind of reset this. Okay, so essentially what happens is that let's see, that's too big. So when you look at main, the code takes two different code paths if you're going to start a server versus starting a client. So, and what it does is that when you run it, it uses clap, it displays this fancy ASCII art looking thing. And by the way, you can make your own of these. It's just, I think, ASCII draw. Yeah, it's ASCII draw. It's this really cool little program, so you can like make your own things that look like that. Let's see, how does this work? So you can do it like that, whatever. So it's pretty cool. Do all kinds of cool stuff like that. Anyway, so I start with this, and then I use something else called this thing. It's really cool. These are all the ASCII characters that are not Unicode that will work in the terminal as is. So there's a lot of really cool stuff. Like if you're ever wondering how ASCII art gets done, it's probably using these things. So we have other Rebel software that uses these glyphs. It's really cool. So you can see like all kinds of strange characters. And these print really just as is on your terminal, believe it or not. These are not Unicode. They're not emoji. They're just old school ASCII. And you can learn more about what ASCII 256 is by going to this onboarding. And there's a whole host of information, like what the heck is an NC escape sequence? Sorry, not ASCII, NC escape sequence. They're in here somewhere. NC. Yeah, what is all this? And you can read all about it. So there's like everything you ever wanted to know about NC escape codes. This is basically how a lot of these things work under the hood. Okay, so coming back to this. So here, when we run the program, uses clap, parses all the command line arguments, and it creates something called terminal async. And this is basically the thing that I wanted to show in this stream is like I'm in the middle of, actually at the start of, I built this thing called terminal async module, and I really need to make it part of readline async, and I'm going to rename readline async to something that makes more sense. I'm not sure what that is yet, but this code, I was kind of, this is like a staging area where tcp-api-server is the customer, if you want to think about it, for this crate. So I wanted to see, like, in the real world, how many features I would need to provide in this crate to make it useful. So I started using it in TCP-API-server. I started removing calls to readline and started replacing them with calls to REST-line async. And I had to do a lot of work. Like I had to make a progress bar from scratch. So I'll walk through this in a different stream. This is all async, by the way. The key is, though, they're all async. That means that they're not they're not blocking, and they work even when there's multiple tasks, background tasks, that are generating output and dumping it into standard out, which is pretty amazing. So there's a whole lot of stuff going on here. This doesn't, it looks pretty complicated, but also at the same time, the output is really simple. And it's complicated and simple at the same time, in the sense that it is complicated under the hood, and the capabilities it's providing is essentially allowing us to make interactive REPLs. So easily, without having to rebuild all this from scratch. So anyway, so I made this thing called terminal async, which is going to be the main thing that somebody will use. And inside of it is a readline and also something like a standard out, and I'll walk through all this later. But these are basically a replacement for printline and readline. So instead of doing printline and readline, you say get readline event. That's the new readline. This is replacement for readline. And you can say this is async, non-blocking. And this is this works concurrently and is async blocking. That means this works concurrently means that multiple tasks can output at the same time, and it is compatible. The prompt displayed, not that the prompt, but the readline with say get readline event. Let's see if that cargo doc no deps, does that work? Nope. What did I do wrong? Oh. So I'm trying to basically hyperlink this thing here, and it doesn't like it, so... Huh. Let's see what it's supposed to be. I don't think this is valid Rust. I stand corrected. Copilot for the win. All right. So this, wow, check that out. Get readline event method. Get readline event. I did not know that. I don't think that's valid Rust. Let's see it. Let's see cargo doc dash dash open. Pretty sure that's not valid Rust. Let's see, which one was that? Readline, I think. No, event readline. How could I forget? What was it? It was I think it's called get readline event. Okay, so let's do this. Where the heck is it? Get readline event. Where did it go? Okay. Is that get readline event? Yeah, see, replacement for readline. It didn't hyperlink it correctly, just like I thought. That's just made up nonsense. Okay, let's ask Copilot in Rust. How do I add a Rust doc that links to a function? There's a way to do this. I keep forgetting because it's unintuitive. Oh, are you seriously? Oh, okay. Let's do that. So it would be get readline. It's lovely how I just want, okay, so it's angle brackets, curly bracket. Okay, so this would be like that, and then let's see if that works. Cargo doc, no depths open. I don't think it worked. Huh. Interesting. Why? Is it itself? Nope. That doesn't work either. Okay, seriously? Broken introdoc links. No, in module terminal. Okay. module terminal. So where is this? Terminal async, and that's in modules. But the module is this terminal thing. So we can do self create get readline. Nope. Bizarre land. Hey, we have a winner. What do you know? So you have to give. Oh, sorry, went too far. What the heck is it? Ah, so here we get an event. Replacement for readline, and am I looking at the wrong? Oh my goodness. Yes, I wasn't even looking at the right function. Okay, so that works. Yikes. Okay, so never mind. I was looking at this, but actually changing that. Oh well. Well, while we're here, what we can do is we can just say this, because this is actually part of the standard library. Standard what? Okay, let's see where the readline std, where are you? It is that. Okay, let's do that. Standard. There we go. So now you can go straight to the implementation of readline. There you go. This is how it's all implemented if you want to go completely crazy. Look at that, unsafe. Nice. Very nice. Okay. By the way, readline, as the name implies, cares a lot about \n, the new line character. So when you write things to standard out or standard error and they don't have a \n at the end of it, it won't flush. So you won't see it. So if you're doing partial characters without a terminating new line, it doesn't work. So this is incredibly difficult to do. These dots that you saw fly by and like, that's not easy to do. That's a very non-trivial problem to solve. But I will go into the details of how that's implemented in different streams. So, okay. So now we have nice documentation. This is just to give you an idea of like how to write these Rust docs and stuff like that, in case you're wondering. Like, so this is cargo doc. You say no deps, and then you can see it'll compile your docs, and then it basically generates this website that's local. I opened it like 50,000 times, but there we go. And then, okay, let's save this. So, because this is a work in progress, I'm just like willy-nilly just saving it as we go. Okay, so this terminal async thing struct is what programs will use in order to access the functionality of readline, and also progress bars. So the way this works is that in the main program for this tcp-api-server, the first thing we do is we initialize this terminal async thing, and this looks like a prompt. Then we create initialize tracing. I'll walk you through all this later. Then we use this terminal async to print line and flush this string, and that's actually what produces this output here. And let me get out of here. So then basically once that header has been displayed, it goes and it starts the client, because I had typed that, client here. So in the client, what it does is that it creates a connection to a TCP server, but before it does that, it starts this progress bar async thing. And just so you can see those dots, because the connection happens immediately, it puts in an artificial delay so you can see the animation. And then it actually connects to the server, which is running here. And then it tells the progress bar that, okay, you can go away now, we connected. And then basically the rest of the program ensues. Whatever there's a whole lot of stuff going on here. That it basically spawns, this is called the green thread. It's in here. Where the heck is it? Yeah, this thing, asynchronous green threads. These are called Tokyo tasks. They're vaguely mapped to operating system threads, but not really. So you can read all about it for Tokyo, but this is how async happens. So a lot of times when you're doing I/O operations, those tend to be blocking. And what that means is that if you're waiting for a file to finish writing, or you're waiting for data to come in from a socket which is connected to a server, or something along those lines, the thread that's waiting is actually blocked, and it can't do anything else. So, which is not that great. So with non-blocking I/O, it's possible to like have that thread do other things and actually have lots of threads. So you're not tied to a single thread or anything like that. So we'll go into Tokyo and async later, but so essentially this spawns, you can think of it as a green thread or a background task. In background is a misnomer. It spawns a task, and it monitors a TCP connection. Then this other task, which it spawns, monitors a channel. A channel is like this really cool thing from Go that Rust also uses. So we have a MPSC channel, multiple producer, single consumer channel, and this is just a way for different pieces of the command line application to communicate with each other. So this will become apparent later when you have really sophisticated command line interface applications. And so yeah, and then there's the main loop. This is the thing that actually displays the prompt to the user. It just displays, says go type something, and this is what you can type, and then that right there is where readline event, this thing, ends up being called. So this is actually where it's used in real life. Still working on it. There's a lot of work that needs to be done to basically get these things to coexist. So take all this stuff in terminal async, put it in the Rusty line crate, rename Rusty line crate to something else that's more representative for what it is, and that can be the focus for the next stream. But yeah, to kind of see how all this is set up, check out the Rusty line async example, the readline.rs. It's really good. It's like an empty version of this thing, the tcp-api-server. This is like super complicated and a lot of stuff going on. But this is like minus all the logic, just the command line interface scaffolding, if you will. So it's pretty awesome. Like if you can understand this, if you can grok this, then you'll have a good understanding of like how command line interface applications can be done, like really nice ones, like stuff we probably don't even know that we're missing until we see it. And there's some ideas from React and all that. So if you're familiar with like front end, there's a lot of interesting ideas that have been brought into here. Like there's a state, very much like React state. And yeah, so this is like a very powerful command line interface that's non-blocking, that's interactive, that has some notion of global application state for rendering purposes, but isn't heavy. So you don't. It's very lightweight, relatively speaking. We have heavier things like Rebel TUI. This thing. This is the full thing. Here you build like the equivalent of whatever desktop application or web application you want in Rust from scratch. The whole thing is async. You have control over every single character on the screen, and it's overkill for simple command line interface applications. So the idea was to take some of this magic and put it in here, but do it in a very low, like in a way that doesn't ask much of the person using the library. Anyway, so on that note, I think I will stop today's stream. Hope you enjoyed it. Please give me feedback, and looking forward to doing the next one.